Let's do an example of how the units on derivatives really works and how we think about what we take the derivative with respect to. So the cost of extracting T tons of ore from a copper mine is C equals F of T dollars. So we want to know first, what are the units on F of T? So F of T is this function whose input is T tons of ore, and the output is the dollars. Okay, so what are the units on F of T? This is dollars. Okay, because F of T is the cost in dollars. Okay, what are the units on F prime of T? Okay, F prime is the derivative of F with respect to T. Okay, what that means is when T changes, when the tons of ore change, how does that affect the cost of extracting T tons? So when we compute the derivative, we take a change in F divided by H, which is really a change in X or change in T. So we get units of F divided by units of T. That's sort of our formula for the units of a derivative. So that's what I should be thinking about. Of course, I wouldn't say units of F. I really want to think about this as cost. It's a cost or it's a dollars. We measure cost in dollars. And instead of dividing, we're going to say, per. And instead of saying units of T, well, T is measured of ton. And this is tons of ore. Okay, dollars per ton of ore. If we change the number of tons, how does that affect the cost in dollars? So if I say that F prime of 2,000 equals 100, what does that mean? Okay, so 200, that's a ton amount. So when 2,000 tons of ore is extracted, the cost is changing. Well, I'm running out of room. It's changing. How? How is it changing? It's changing by approximately $100 per ton. Okay? And this really does depend on the specific value of 2,000. If less or more ore is extracted, the cost might be changing by less or more. Okay, but right now, when there are 2,000 tons of ore is extracted, the cost is changing by approximately $100 per ton.